Good day, grade 10 learners. Welcome to our mathematics lesson. I am Skulile Ngube, and this lesson is proudly brought to you. This lesson is proudly brought to you by the Gauteng Department of Education. Okay, right. Today, grade 10s, we are going to look at the mutually exclusive, exhaustive, and complementary events. We're going to look at mutually exclusive, exhaustive, and complementary events. Let's be ready for our lesson, grade 10s. Make sure that your book is there with you. And then also you have your pens, calculator, and everything. Okay, right. So we're going to define complementary events. We're going to do calculations involving mutually exclusive, exhaustive, and complementary events. Okay, right. Now, I want us to do this baseline activity before we do anything. Right? Deriving the probability identity or the addition rule. Right, we're given the sample space there. Outcomes when rolling a single dice. These are the outcomes. And then event A is getting an even number. These are the even numbers. Then event B is getting a factor of 6. These are the factors of 6. I want you to show that the probability of A or B is equal to probability of A plus probability of B plus probability of A and B. I want us to do that. Just show that the left-hand side, which is probability of A or B, is equal to the left-hand side, which is probability of A plus probability of B minus probability of A and B. Let's do that for 5 minutes. Welcome back, greetings. I really hope you managed to get the correct answer. Okay, probability is not difficult, greetings. It's very, very easy. We must get all the marks here. Have you written your exams yet? Okay, make sure that you understand what you're going to learn here as you prepare for your examination. Some of the questions that I'm going to show you are coming from past examination papers, okay? So you must see how you are asked in the exam when it comes to what? To probability, right? So now, we want to see if the left-hand side probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Let's look at these things one by one. What is probability of A or B? Probability of A or B. Remember, these numbers is not like we're saying here there are 4 items. No, it's just one outcome. 4 is an outcome. These are the outcomes. 1, 2, 3, 4, 5, 6. So when you're saying 6, we count it as one item. 5 is one item. You see that? Okay. So we have 4. Probability of A or B, we have 4, which is 1, 2, 3, 4, 5. In our previous lesson, we talked about the Venn diagrams. We now understand which items should we look for when you're saying probability of A or B. So you're finding these items which are in event A and event B. A union B. Do you remember that? Okay. So what's the probability there? We counted how many things? 5 things. So the probability is 5 out of, or where is it? Okay, 5 out of 6. You see that? That is probability of A or B. We've done this part. What about the probability of A? Look at the circle A. Out of 6 outcomes, probability of finding A, what is it? How many things are in A? 1, 2, 3. Remember, we're counting A, not A only. A only will be 4. But A, we're counting all the 3 items. So it is 3 out of 6. Let's leave our denominator as 6. Let's not simplify the fraction so that when we add them, we're going to have fractions with the same denominator. Okay? Right. This is the probability of A. What is the probability of B? We are revising still. Okay? What is probability of B? Say the answer. It's going to be, let's see, 1, 2, 3, 4. Is it 4 out of 6? Yes, it can reduce to 2 over 3, but let's leave it as 4 over 6 now because we are going to be adding these fractions. What is left? Probability of A and B. Probability of A and B. Which part of the Venn diagram is this? The intersection, where the events intersect or overlap here. How many items are in this section? 2 out of 6. You see that? 2 out of 6. Now we're going to substitute this, and this into this. We want to see if the left-hand side is going to be equal to the right-hand side, isn't it? Right, let's just do that. Right, and then we have substituted here. The denominators are the same, so we can deal with the numerators there. 3 plus 4, what is it? 7, isn't it? 7 minus 2 is 5. So this whole thing is 5 out of 6. Now, do you see that? Probability of A or B is equal to the probability of A plus probability of B plus probability of A and B. Remember this identity, please. Remember, don't forget it. For inclusive events, we know that probability of A or B is equal to probability of A plus probability of B minus probability of A and B, which is called the addition rule. Let's write this one down. We have proved that. Now we're going to be using it. We're going to be using it from now. Just 1 minute for you to take your short notes. Let's do that. Right, welcome back, grade 10s. I really hope you managed to take a few notes there. Let's move on. Right, now, so we've discovered that for inclusive events, what are inclusive events? These are the events that have an intersection that overlap. The addition rule is probability of A or B is equal to probability of A plus probability of B minus probability of A and B. We just proved that. So remember, grade 10s, inclusive events are events that have common elements. They have an intersection, they overlap. There is something between which is in A or B, if you're talking about events A and B. It's not about events A and B every time. So I'm just using this as an example. Okay? Right. Now, so there is an intersection. The probability of A and B is actually not equal to 0. It is something else, maybe 0.5 or 0.3, something like that. Okay? Right. So there is an intersection. What will happen to mutually exclusive events? Do you remember mutually exclusive events? What is the difference between inclusive events and mutually exclusive events? Mutually exclusive. There is inclusive and then exclusive. Mutually exclusive events, what will happen to this addition rule? Because mutually exclusive events, the probability of A and B is 0. Like in our previous lesson, we used our good example. We're going to continue with that good example of learners doing mathematical literacy and mathematics. We don't have a learner that will be doing both because you have to choose one, isn't it? So now the probability of mathematics and mathematical literacy is 0. So it means this intersection here is 0. So how will this addition rule change? What do you think is going to happen? Okay, let's find out. So now, mutually exclusive events are events that cannot occur at the same time. Like for example, if you throw a dice and I say, I want numbers that are greater than 5 and also even. It's an even number. 6 is greater than 5. 6 is an even number. So you see that 6 is occurring at the same time, being an even number and greater than 5. So for mutually exclusive events, we don't have an intersection. Right, the events do not intersect or have any elements in common. We're saying that probability of A and B is equal to 0. You see that? So that changes our addition rule. Do you remember our addition rule? I said you must write it down. So that changes our addition rule for mutually exclusive events. So it means here we're going to substitute and replace this with 0. So the probability of A or B for mutually exclusive events is going to be just this part. Understand that? Okay. Since for mutually exclusive events, probability of A and B is equal to 0, then we are going to replace this with 0 like this, and then we remain with this. Okay, please write it down and then specify and write that for mutually exclusive events. Okay, do that. Just for 30 seconds, I'll wait for you here. 30 seconds, just write that. Just this is fine for mutually exclusive events. Okay, should be done by now. I forgot to remind you about our WhatsApp line 079-454-9535. That's our WhatsApp line 079-454-9535. Please give us your input, give us the questions, even sending us your work. That would be great. Okay, please, if there's something you want us to do, maybe you don't understand something, send your questions. Right, so now we have learned about the addition rule for inclusive events and mutually exclusive events. Right, if events A and B cover all elements of the sample space, they are said said to be exhaustive. I'll go back to our good example. I come to your class. I'm an English teacher. I'm teaching all the learners in the classroom. Okay? Right. And then I say, learners who are doing mathematics or mathematical literacy, please stand up. How many learners will stand up? If I say learners who are doing mathematical literacy or mathematics, please stand up. How many learners are going to stand up? Everyone is going to stand up because everyone does mathematics or mathematical literacy. There's no one who's going to remain sitting down. So these two events, mathematics and mathematical literacy, they are taking everyone. Exhaustive. What is to exhaust? It's like finishing, sort of. Okay, something like that. Finishing, exhausting. I've exhausted my funds. I've finished my funds. So these two events take everyone. Let's say the classroom is the sample space. So these two events, they take everyone in the sample space. So they are exhaustive. Okay, right. So if events A and B cover all elements of the sample space, they are said to be exhaustive. Take note, we are going somewhere. We have talked about mutually exclusive events. Now we're talking about exhaustive events. Okay? And then we are going to be talking about complementary events. And then for you to understand complementary events, you must understand exhaustive events and mutually exclusive events. Okay? Right. That's good. Now let's continue. For exhaustive events, probability of A or B is equal to 1. If there are 30 learners, 10 doing mathematical literacy, 20 doing mathematics, I say those who are doing mathematics or mathematical literacy, stand up, it will be 30 out of 30, which is 1. So write this one down. Probability for exhaustive events, probability of A or B, it is equal to 1. Please write it down. Probability of A or B is equal to 1. You write as we move because there's just a small piece there. Right. And then consider this sample space. We have numbers from 1 up to 10. This is not a dice, just a sample space given these numbers from 1 up to 10. And then we have these events. Event A, numbers less than 5. These are the numbers. When I'm saying numbers less than 5, it means 5 is not included. And then numbers greater than 3. 3 is not included, but 4 is there. So these are the numbers. If you check these two sets or these events, do we have a common element? We have a common element. 4 appears in event A, 4 appears in event B. Okay? So now, if we represent this on a sample space, it's going to look like this. Okay? So are these events, have they taken everything from the sample space? Let's check the sample space. 1 is there. 2 is there. 3 is there. 4 is there. 5 is there. 6 is there. 7 is there. 8 is there. 9, 10. So these two events have taken everything from the sample space. So such events are what? Are exhaustive. They've taken everything from the sample space. They are exhaustive. So we're saying that probability of A or B is equal to 1. A and B are exhaustive events. Okay? Right. You want to take short notes? Just 1 minute. Let me give you 1 minute. And then we'll continue after 1 minute. Right, welcome back, great turns. Now, events A and B cover all elements of the sample space. They are said to be exhaustive. We talked about that. And then we've talked about these 2 points. Now, let's look at this situation now. Same sample space, but now event A, we're saying numbers less than 5, which are these numbers. And then numbers greater than 5. These are the numbers. Right. Let's represent this one on Venn diagram. But before we do that, have these events taken everything from the sample space? Before we even go to the Venn diagram, let's check. 1, 2, 3, 4, 5. Where is 5? It's not there. It's not in event A. It's not in event B. Okay. Then 6, 7, 8, 9, 10. You see that? So these events have not taken up everything in the sample space. 5 is still outside these 2 events. You see that? And our Venn diagram is going to look like this. You see, 5 is outside the events. What can you say about these 2 events? They are not exhaustive, but they are what? They are mutually exclusive, if you check, because they don't have an intersection. They are not exhaustive because they are not taking everything in the sample space, but also they are what? Mutually exclusive. They don't have an intersection. Okay, so probability of A or C, that's the sample space there, or probability of A or C, sorry, 5 is not there. Okay, it's outside the events. So probability of A or C is 9 out of 10, which is not equal to 1. So these 2 events are not exhaustive. Right, they are not exhaustive, but they are mutually exclusive. Okay, I really hope you understand these types of events. Right, now we have talked about the mutually exclusive events and exhaustive events. So mutually exclusive events, 1, they don't have an intersection. Okay, and then exhaustive events, the probabilities add up to 1. So if the events are mutually exclusive and exhaustive, they are called complementary events. Write it down, please. 1 minute. Mutually exclusive and exhaustive events are called complementary events. Example again, our good example is the situation we have in our classroom concerning mathematical literacy and mathematics. These are mutually exclusive events which are exhaustive. Therefore, these 2 events are complementary events. Okay, right. Write the sentence or this statement just for 1 minute, then we'll continue after that. Right, welcome back, grade 10s. I was also thinking of another example that I can use for these mutually exclusive events and exhaustive events. Let's think of this one. Let's talk about this one. Let's say when you're getting your report, okay, without checking how the quality of passing or can you say the quality of failing, the quality of passing, right? But it's either you're promoted or not promoted, or you've passed or you've failed, isn't it? Those are 2 events: promoted, not promoted. You see that? Okay, so now those events are mutually exclusive and they're exhaustive. isn't it? Okay, so let's consider this one here, the sample space that we used. We have numbers less than 5, which are these numbers, and then numbers greater than or equals to 5. You see that? Now 5 is there. So these two events, if you check, they are exhaustive because they take everything in the sample space. Every item that you see here is inside A or B. Okay? Or sorry, A or D. And then these events, they are also mutually exclusive because they do not what? Intersect. So this is a good example of complementary events. Okay, this is a good example of complementary events. So now, going back to our probability identity, we said complementary events, probability of A and B is equal to 0. And then what did you say about probability of A or B for complementary events? It is equal to what? Is there in your notes? Check the notes that I said you must write. Probability of A or B for complementary events, what is it? It is equal to 1. For complementary events, probability of A or B is equal to 1. So you put 1 there, and then you put 0 there. So basically, we remain with this. Okay. You see that? So probability, let's use promoted and not promoted. The probability of being promoted plus probability of not promoted will give us 1. Okay. Right. Now, if I will say, if the probability of being promoted, let's say probability of promoted, is equal to 75%. You can use decimals, you can use fractions, you can use percentages. Right, this is the probability of what? Being promoted. It's going to be funny now, but let me try. What is the probability of not? Okay, let me use pass and fail. That one will be easy. Right, let's say pass for P for pass. This is the probability of passing is 75%. What is the probability of not failing? Okay, let me start with the failing one. If the probability of passing is 75%, what is the probability of failing? Remember, probabilities, they must add up to 100%, isn't it? So if the probability of passing is 75%, what is the probability of failing? Failing is going to be 25%, isn't it? Okay, because they must add up to 100%. Now, if the probability of passing is 75%, what is the probability of not failing? What is the probability of not failing? It is the same as the probability of passing. Do you see that? Probability of not failing is the same as probability of what? Of passing. Okay, so that's what we're going to discuss now. Right, let's move on. So I'm saying probability of A plus probability of B is equal to 1, but B is just the same as not A for complementary events. B is just the same as not A. Like there we say that the probability of not failing is just the same as the probability of passing. Does it make sense? Okay. Right, so the probability of B is just the same as the probability of not A. Okay, so there, where there is probability of B, we can replace that with probability of not A. And then we get our equation for complementary events. You see that? And then this is just the same as probability of B, probability of not A. Okay, and then we can rearrange our equation and write it like this. Please write this one down for complementary events. And then say for complementary events. Okay, so what have we learned so far? We've learned about these types of events, inclusive events, mutually exclusive events, exhaustive events, and complementary events. Complementary events is events that are exhaustive and mutually exclusive. Okay, right. Now, let's move on. Right, now we're going to the activities now. I'm going to be giving you time to do the activity, and then after that we discuss, isn't it? Right. Numbered balls are placed in a box there are 12 balls. It means there's ball number 1, ball number 2, ball number 3, up to 12. There are 12 of them. A ball is drawn and replaced. It means you pick it up and you put it back. So the number of balls there is maintained. It does not change. And then the following events are given. A is equal to drawing or taking out an even number. And then C is drawing, which means taking out. Drawing there meaning taking out. C is drawing a number greater than or equal to 7. Draw a Venn diagram to represent these events A and C. Let's try to do that. Maybe you can start by writing the actual items here. Even numbers from 1 up to 12. Write them down. And then C, numbers greater than or equal to 7, write them down. Okay? And then you can easily see if there's an intersection. If there's an intersection, you start with it and then you draw your Venn diagram. Let's try to do that in 5 minutes. Right, welcome back, grade 10s. Let's see how we're supposed to draw this Venn diagram. So, A, drawing an even number. So it means A will be, we start with what? Even numbers, 2, 4, 6, 8, 10, 12. Okay. And then C, a number greater than or equal to 7 is 7, 8, 9, 10, 11, 12. Okay. Right. And then now, if you check, do we have, there's a 12 there and a 12 there. We have an intersection. We have 10 there. We have 10 there. We have an intersection. And then 8 there and 8 there. Okay. Do we have any number which does not appear here? If you check, 1 is not there, 3 is not there, and 5, they're not there. They're outside these two events. You see that? So these events are not exhaustive. Do you see that? Because they're not taking everything in the sample space. So let's draw our Venn diagram. This is our Venn diagram. So intersection there we have 8, 12, and 10. And then A only is going to be the 2, 4, 6, 10 is found in A and C. 8 is found in A and C. Or these three are found in A and C. So let's do them. That is A only. So it's 2, 4, and 6. And then C only, there's 7, there's 9, and 11. And then we find 1, 3, and 5 outside the two events. You see that? That is the Venn diagram. Okay? So these are type of questions you're going to get in the exam. And then determine the probability of A or C. Probability of A or C. Let's try to do that in 1 minute. Probability of A or C. I'm going to be giving you questions now. You answer them, I give you the answer. Give you the question, you try it, I give you the answer, like that till we end. Okay, let's try for 1 minute. Right, welcome back, grade 10s. What did you get? Let's mark our work. Probability of A or C. Which items are we counting here? These items. Out of how many? 12, ne? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means it is 9 out of 12, which reduces to 3 out of 4. Mark your work. Did you get it right? Okay, good. Okay, and then we go to probability of A and C. Let's do it for 1 minute. Probability of A and C, 1 minute. Right, welcome back, grade 10s. Now, how many items do we have in the intersection? 1, 2, 3. So it means 3 out of 12, right, which is 1 out of 4, right? Remember, we found the first question there. Oh, we started by drawing the Venn diagram. Then after the Venn diagram, we found the probability of A or C. It was 3 out of 4, not equal to 1, meaning that the two events were not or are not exhaustive. Right, and then here the probability of A and C is not equal to 0, meaning that these two events are not mutually exclusive, but they are inclusive. You see that? Okay, so now you get a question to say, show by using rules that probably A and C are inclusive but not exhaustive. They are inclusive because the probability of A and C is not equal to 0, and they are not exhaustive because the probability of A or C is not equal to 1. Okay, right, you get such questions. They ask you, why are these two events exhaustive? Why are they not exhaustive? Are they mutually exclusive? Why are they not mutually exclusive? Something like that. Okay, you should be able to use this to explain your answer. Right, let's move on to the next question. Right, again, it's coming from a past examination paper. An entire sample space is made up of two complementary events. Please take note. So you must know, when you're talking about complementary events, what are we talking about? Where the probability of not S is 0.33. Complete the statement and then write down the value of probability of T. It says write down, not even calculate, write down, using what we have discussed. Can you answer these two in 1 minute? A and B in 1 minute. Right, welcome back, greetings. So if events S and T are complementary events, therefore probability of S and probability of plus probability of T is equal to 1. Okay, do you remember that? Right, write down the value of probability of T. What did we say? Remember when I used that example of passing and failing? Okay, so the probability of T is just the same as the probability of not S. Because I think probability of S plus probability of T is equal to 1, then this is just the same as probability of not S. Okay, and then the probability of not S is given, which is 0.33. So the probability of T is also 0.33. Remember that, okay, from our complementary events knowledge. Okay, right. Now let's move on to the next one. For two events, A and B, it is given that probability of A is 0.30, probability of B is equal to 0.65, and probability of A or B is equal to 0.74. Calculate the probability of A and B, that's the first part. And then after that, it says hence, meaning that you must use the answer you got in A. Hence, represent the above information in a diagram. And then, are the events A and B mutually exclusive? Give a reason. Right, I want you to do these three, A, B, and C, in 5 minutes. And then after 5 minutes, we're going to mark our work. Let's try. Welcome back, cretins. Did you manage to get the answers? Let's mark our work. So what do we start with? We have our addition rule. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Let's substitute what we are given, isn't it? We are given this 0.74 there. We are given this 0.30. We are given this 0.65. Then we're going to find our probability of A and B. Okay, let's substitute what we have there, and then we can transpose everything this side. 0.74 minus 0.3 minus 0.65. We get that probability of A and B is equal to 0.21. Okay, you will get negative 0.21 this side. Then you divide by negative 1 on both sides of the equation. You will get this answer. Please mark that. Hence, represent the above information in a Venn diagram. Hence, represent the above information in a Venn diagram. So, do we have an intersection? Yes. We start with it. So, that is our intersection there. Right. Oh, my Venn diagram just came once like that. Right. How did we get 0.09? How did you get 0.09? I don't see 0.09 anywhere there. How did you get 0.44? I can't see it anywhere. Okay, so we have the probability of A and B, and then the probability of A, the whole A, is 0.3. You see that? And then if you say 0.3 minus 0.21, that's where this 0.09 is coming from. So it is this and this that gives us 0.3 if you add them. Same thing this side. Okay, the whole B is what? 0.65. And then if you say 0.65 minus 0.21, you'll get 0.44. But if you add these two, you'll get 0.65. Right. Now, if you add this, and this, and this, and this, what must we get? Let's put a question mark here. Let's say we didn't know that. We must get 1. So you add 0.09. Did I bring my calculator? I didn't bring it. 0.09 plus 0.21 plus 0.44. You add those and then get the answer and then subtract from 1. You'll get 0.26, which is outside the two events. Are these two events mutually exclusive? Are they exhaustive? I think there's a question about that. Okay, let me wait for now. Right, and then that is B, and then C. Are these events A and B mutually exclusive? Give a reason for your answer. Right, these two events are not mutually exclusive because probability of A and B is not equal to 0. Okay, probability of A and B is not equal to 0, so they are not mutually exclusive. Are they exhaustive? No, they are not exhaustive because these two events are not taking everything in the sample space. Okay. Right, we're left with 2 minutes. Let me try to explain this one in these 2 minutes, then we'll be done. A survey was conducted among 180 residents of a small town to establish how many people contracted tuberculosis and or human immunodeficiency virus during the last 5 years. The results were as follows. X people were diagnosed with TB. Then 30 people were diagnosed with TB and HIV. 69 people were HIV positive. 51 people did not have either disease. Represent the information in a Venn diagram. So what are we going to start with? When you're asked to draw a Venn diagram, start with the intersection, which is this in this case. 30 people were diagnosed with both TB and HIV. You start with that, okay? So that is the intersection here. And then it says X people were diagnosed with TB. So it means the whole circle for TB there is X. And then how do we get TB only? We will say X minus 30. You see that? X minus 30 because X is the whole circle for TB. So this is X minus 30, right? And then 69 people were HIV positive And then how do we get HIV only? You say 69 minus 30, which is what? Which is 39. Do you see that? And then 51 people did not have either disease. So they don't have TB, they don't have HIV. So it means it's outside the two events. You see that? We have represented the information on the Venn diagram. And then the next questions are based on this one. How many people contracted TB only? So it means we need to find our X first. How are we going to do that? There were 180 residents. Okay, just listen for these few minutes. So we add X minus 30 plus 30 plus 39 plus 51. We must get 180. And then we solve for X after that. So we add this, and then we get that X is equal to 90. So therefore, X is equal to 90 people. Right. And then now they said TP only, you say 90 minus 30 because X is 90. So 90 minus 30, which is 60 people. Oh, sorry, 60 people. See that? Okay. Calculate the probability that a person selected at random will only have been diagnosed with TB. So it's going to be 60. Where is it? Calculate the probability that a person selected at random will only, okay, TB only. Right, TB only, we said 90 minus 30, which is 60. So it's 60 out of 180. Okay, which is 1/3. Okay, right. And then calculate the probability that a person selected at random will not have any of the two diseases. These are the people that don't have any. So it's 51 out of 180. Okay, so that's probability there. Right, the last part we rushed, but I really hope you gained something from it. Okay, so we're going to meet in our next lesson. Right, you can pause the video here and write your what? And write your, copy the homework. You can go back and copy the homework and pause the video and copy the homework. Okay, right, so we are done with today's lesson, grade 10s. We are going to meet in our next lesson. Okay, this is the summary. If events A and B cover all elements of the sample space, they are said to be exhaustive. For exhaustive events, probability of A or B is equal to 1. Mutually exclusive exhaustive events are called complementary events. And then for complementary events, probability of A is equal to 1 minus probability of not A. Please take note of that. For inclusive events A and B, the addition rule is like this. Okay. Right. Thank you very much, grade 10s. We're going to meet next week. Next week, we're going to be doing simple and compound growth. We're going to meet next week when we start financial maths, including just simple and compound growth. Remember, we can talk about the growth of bacteria and other things. It's not about financial maths only. So we'll meet next week, grade 10s. Goodbye.